Now we see the selection of one or more objects from a given number of objects. So in which let's consider the first case when all the objects are different, that is no two objects are identical. Let's consider that in all there are say n objects. Now as we are interested to know in how many ways we can select one or more objects, let's first consider in how many ways we can select one object. So that is clearly given by NC1. Similarly, number of ways to select two objects out of n objects is given by NC2. And similarly for 3 objects it will be NC3 and so on. Till finally we have NCn, that is number of ways to select all the n objects from n objects. So hence the total number is nothing but the addition of all these terms. And we know that the sum of all these terms is nothing but 2 raised to n minus 1. So therefore that is the required answer, that is number of ways of selecting one or more objects from n different objects. Now let's go to the next case where it might be possible that say p objects are of one kind, that is p objects are identical to each other. Then q objects are different than the previous p objects, but the q objects themselves are again identical to each other, and so on. And it may happen that there are say k objects, the remaining k objects, which are different than each other. So in this case here let us think of the first set of objects, that is there are in all p objects which are of the same type. Then we have q objects of different type but identical within themselves, and finally we have k objects which are not same as the previous two sets, but they are still different within themselves. Now if we concentrate on the first set, that is there are p objects of the same kind. Now out of this, since all the p objects are identical, even if we choose any one of them, it is going to be the same event, that is it does not matter which one we choose from those p objects. Similarly, when we choose say any two objects out of the p objects, it is same as selecting any other two objects from the set of p objects. So hence selecting at least one, or selecting 2 or 3, and up to selecting all the p objects in all can be done by p ways. We still have to consider the possibility, that is it may happen that in the entire set of all these objects given, that is p, q and k, it may happen that we don't select any object of the first set but select some of the objects from the remaining sets. So that means to cater for the possibility that no object from the first set is considered, we have to add 1 to the total number of count which we have covered earlier. So therefore in all the total number of ways of selection from the first set is p plus 1, because we consider the possibility that none of the objects from this set might be chosen. So similarly we have q plus 1 possibilities for the second set. Now if you come to the last set, in which there are k objects but each of them is of different type. So referring to the previous case that we saw, the total number of ways to select any one or more will be actually 2 raised to k minus 1, but here we have to first consider the possibility that we are not selecting any object out of the k objects. So the final count will be obtained by first multiplying these individual counts, but as we have seen earlier, that is this particular product includes one possibility in which we are not selecting any object of any kind, so which of course we don't want, because overall we want at least one object. So therefore from this product we have to subtract 1, which is the final answer. So based on how many objects are identical, we can generalize this formula and get the answer. Now let's see some of the examples which are based on these concepts. In how many different ways is it possible to draw a sum of money using a rupee and the various coins which are given here, that is 50, 25, 10, 5, 3, 2 and 1 paise. So now if we see, there are 8 types of coins given and all the coins are of different type, that is a different value. So here we may say that n is equal to 8, and to make a particular sum of money is nothing but to select at least one coin out of these 8 coins. So that can be clearly done in 2 raised to 8 minus 1 ways, which is nothing but 256 minus 1, that is nothing but 255. So there are 255 different ways to draw a sum of money using these coins. Let's go to the next question. Out of 3 different maths books, 4 different physics books and 5 different chemistry books, how many different selections can be made so that each consists of exactly one book on each subject, at least one book on each subject and at least one book? So now here let us consider the first sub question, that is exactly one book on each subject. And now here we see that for maths there are 3 different books. So exactly one book out of 3 books can be selected in 3C1 ways. Similarly for physics, out of 4 books we can select one book in 4C1 ways. And lastly for chemistry we have 5C1 ways. So that is nothing but the product of 3, 4 and 5, so which turns out to be 60. Now coming to the second sub question, where we have to think of at least one book on each subject. So now here we may include one or more books also for a particular subject. So that means let's consider maths. Now for maths we have 3 different books. So we have total 2 cube minus 1 ways to select at least one book on maths. We have to subtract 1 because if we don't subtract, then the 2 cube, that is 8 possibilities, also include the possibility where we are not selecting any maths book. So therefore we have to subtract 1. So similarly for physics also we have 2 raised to 4 minus 1 ways, and for chemistry we have 2 raised to 5 minus 1 ways. So therefore if we simplify this, we get 7 into 15 into 31, which turns out to be 3255. Now let's see the last sub question, which is saying we have to select at least one book in general. So now here the subject is not mentioned as such. So therefore if we are not distinguishing between the subjects, we can just think of the entire collection as the set of nothing but 3 plus 4 plus 5, which is nothing but 12 books. So we are not having any difference between the subjects. So therefore to select at least one book out of these 12 books, that can be given by 2 raised to 12 minus 1. So these are the number of ways to select at least one book in general.